So one of the type of reactions alkanes have, basically all organic compounds can undergo this kind of reaction, which is called combustion. Combustion is like, basically we can call it burning, or we can say mixing with oxygen at the proper condition. So combustion is a rapid oxidation that takes place at high temperatures and converting alkanes to carbon dioxide and water. Little control over the reaction is possible except for moderating the temperature and controlling the fuel over air ratio to achieve efficient burning. So basically, for organic compounds combustion, we need to have certain amount of oxygen in order to have the complete reaction. If we have the complete reaction or complete oxidation or complete combustion, the final product has to be CO2 and water, nothing else. But if we don't have enough or sufficient oxygen, we will not have only CO2 and water. Besides, we have some others like Coke or CO and maybe other products. So if we have complete reaction, we must have CO2 and water. So as you see here, the reaction has to be CnH2n plus 2. As you know, that is the empirical formula for alkanes, CnH2n plus 2 plus excess oxygen. Why excess? We usually need to provide excess oxygen in order to make sure that the reaction is complete. And we heated them, and in the product side we have NCO2 plus N plus 1 H2O. For example, for combusting of propane, we require 5 moles of oxygen for 1 mole of propane, and it gives us, under complete condition, complete combustion, we will have 3 moles of CO2 and 4 moles of H2O. Unfortunately, the burning of gasoline and fuel oil pollutes the air and depletes the petroleum resources needed for lubricants and chemical feedstocks. Solar and nuclear heat sources cause less pollution and they do not deplete these important natural resources. Facilities that use these more environment-friendly heat sources are, however, more expensive than those that rely on the combustion of alkane. Besides, there are some other. The control is, for example, for nuclear heat sources, the control of the process is really hard. So that's basically the combustion of alkanes. As I said earlier, we can have combustion for any kind of organic compounds. So based on the chemical structure of the organic compounds, we need to estimate how much oxygen we need in order to have complete combustion. Sometimes in organic compounds chemical structure, we have some other atoms like S or N, like not nitrogen and sulfur. So whenever it undergoes combustion, we will have some other compounds in the product side, such as nitrogen oxides and sulfur oxides. If you want to learn more about nitrogen oxides and sulfur oxides, you can go to my video for air pollutants in NOx and SOx videos series. We have it. I talked about those kind of chemicals in those videos.